Okay, the first thing we're going to talk about when it comes to encryption is passwords. And passwords and Keyspace. Those are the two terms that I really want you to get. So your password is, as you know, that is the special key that you have chosen to use to get you access to a system. Keyspace is the set of all possible passwords that you could use. Let me give you an example. Let's say that we live in a world where your password can only be digits, 0 through 9. So you don't have a full keyboard, you just have that little keypad on the end. And furthermore, let's say that your password is exactly 1 character long. Well, if we look here, I could choose any of these characters as my password. Let's say I choose 5. So my password is 5. Now, if somebody else comes along and they know my username and they try to get access to the system, how many passwords do they need to try in the worst case in order to get in? Well, 10, right? I only have 10 possibilities. That's my key space. So in this case, my password is 5 and my key space is 10. So obviously that's easy for a human being to crack. For a computer or somebody running some type of software, that's near instantaneous. So that's not nearly secure enough. What we'd like is to have a bigger key space. So it needs to try more values before it finds our password. So how could we do that? Well, one thing we might do is we might increase the number of characters in our passwords. So let's say instead of being a single character, it's 2 characters. Now all of a sudden, we have a lot more possibilities. So our lowest password is 00, and then 01, 02, 03, all the way down, and our largest password is going to be 99, right? So now our key space is 100, which is 10 squared. Where does that come from? Well, we have 10 possibilities for the first digit. Once you choose one of those, you have 10 possibilities for the second digit. 10 times 10 is 10 squared. And in fact, every time we add another digit to our password, we increase this exponent here. So if it's 3 characters, it'd be 10 to the 3, 4, etc. That's why most password complexity rules have that minimum length requirement. Every time you add another digit, you add another exponent. But suppose that's not good enough. Suppose we want to make it even more secure. Well, another thing we can do is let's not only use digits, 0 to 9, right? That limits this bottom part here to 10. What if we add in our regular characters, our regular letters? Well, now I have 36 possible digits, right? So now with 2 letters, it's 36 squared. Well, what if I treat uppercase and lowercase different? Now we have 26 plus 26 is 52 plus 10. Now we're looking at 62 squared. What if we add in special characters like exclamation point, question mark, that type of, every time we add a character, we increase this bottom number, which thereby increases our key space. It increases the total number of possible keys that a bad actor would have to try in order to brute force attack. That's what we call it when you just try everything. Brute force attack this password. Okay, so that's your password and your key space. So then the question is, why do password complexity requirements force me to have it at least 6 letters long and force me to have it use uppercase and lowercase and numbers and yada, yada, yada? Isn't it enough that I could use them that would force the hacker to try all those possibilities? Yes and no. Hackers know that human beings are inherently lazy, incredibly lazy, and they will try the simplest password requirements first. That is, they'll try all lowercase, they'll try short passwords. They'll go through that list first before they go check anything else. So if your password is not complex enough, they will find it pretty quickly. Another rule that many password complexity requirements force on you is no dictionary words. Right? It might kick it back and say, hey, this is no good because it's based on a dictionary word. That's because most hackers know that human beings are not very good at remembering a random string of letters and numbers and symbols. So what we do is we use words to remember it. So hackers program their attack methods to just start with a dictionary. Let's go down the dictionary and try all those words first. which is still a lot of words, but a lot less than trying every single possibility. So your password manager will kick that back. Okay, I hope that password complexity requirements and Keyspace and passwords all kind of make sense now. If you have any questions, shoot me an email.